What if everything you've been told about reality is just a carefully constructed illusion? What if the greatest minds in science have uncovered truths so disturbing that they've chosen silence over revelation? Throughout human history, there have been discoveries that shake the very foundation of our understanding. Theories so unsettling that they're whispered about in academic corridors, but never shouted from the rooftops. Today, we're going to explore 10 of the most terrifying scientific theories that rarely see the light of day. Concepts that challenge everything we think we know about existence itself. These aren't conspiracy theories or unfounded speculations. These are legitimate scientific hypotheses, mathematical possibilities, and observable phenomena that have profound and often deeply unsettling implications. Some of these theories suggest that consciousness might be nothing more than an elaborate trick. Others propose that our entire universe could blink out of existence at any moment. Still, others hint at the possibility that we're living in a simulation, or that our reality is just one of infinite parallel worlds where every possible outcome has already occurred. The silence surrounding these theories isn't always about suppression or conspiracy. Sometimes, it's about the sheer weight of what these ideas mean for humanity. When a theory suggests that free will might be an illusion, or that the universe is fundamentally indifferent to our existence, scientists often hesitate to broadcast these findings to a world that might not be ready to hear them. But ignorance, as they say, is only bliss until reality comes knocking. Let's begin our journey into the shadows of scientific thought with a theory that strikes at the heart of what it means to be human. The conscious observer paradox. Imagine for a moment that consciousness itself is the only thing holding reality together. Not metaphorically, but literally. This isn't some mystical notion from ancient philosophy. It's a genuine puzzle that emerges from quantum mechanics, one of the most rigorously tested theories in all of science. At the quantum level, particles exist in what scientists call a superposition, essentially being in multiple states at once until they're observed. This isn't a limitation of our measuring instruments or a gap in our knowledge. The mathematics and experiments consistently show that observation itself causes what we call the collapse of the wave function, forcing particles to choose a definite state. The famous double-slit experiment demonstrates this perfectly. Fire electrons one at a time through two slits, and if you're not watching which slit they go through, they behave like waves and create an interference pattern. But the moment you set up a detector to observe which slit the electron passes through, the interference pattern disappears, and the electrons behave like particles. It's as if reality itself changes based on whether or not consciousness is paying attention. Now here's where it gets truly disturbing. Some interpretations of quantum mechanics, particularly the von Neumann-Wigner interpretation, suggest that consciousness might be fundamental to reality itself. Without a conscious observer, the universe might exist only as a cloud of probabilities, never solidifying into the concrete reality we experience. This raises a terrifying question. What happens to reality when there's no one around to observe it? Think about the implications. Before conscious life emerged in the universe, was there even a universe at all in any meaningful sense? Or did the cosmos exist in an eternal state of quantum limbo, waiting for the first spark of awareness to collapse the wave function and bring reality into being? And if consciousness is required for reality to exist, what happens to the parts of the universe that no conscious being has ever observed? Some scientists have proposed that perhaps the universe has a kind of collective consciousness, or that observation doesn't require biological consciousness at all, that any kind of interaction counts as observation. But these explanations feel like attempts to sidestep the deeply unsettling implications of the original finding. There's an even darker possibility lurking here. If consciousness creates reality through observation, then what you perceive as the world around you might be fundamentally different from what I perceive. We might be living in overlapping but distinct realities, each one called into existence by our individual consciousness. The person sitting next to you on the bus might be experiencing a completely different universe than you are, one that only seems to align with yours because of some underlying structure we don't yet understand. This theory suggests that reality might be far more fragile and subjective than we've ever imagined. It means that the solid, objective universe we've been taught to believe in might be nothing more than a collaborative hallucination, a shared dream that could dissolve the moment consciousness looks away. The heat, death, and the end of meaning. The second law of thermodynamics is one of the most ironclad principles in all of physics. It states that in any closed system, entropy always increases over time. In simpler terms, everything tends toward disorder. Your room gets messy unless you actively clean it. Buildings crumble unless maintained. Stars burn out. And the universe itself is slowly dying. This isn't speculation or one possible future among many. According to our best understanding of physics, the heat death of the universe is inevitable. Given enough time, trillions upon trillions of years from now, every star will have burned out. Every black hole will have evaporated through Hawking radiation. The universe will reach a state of maximum entropy, where no energy differences exist to power any kind of work or change. In this final state, the temperature of the universe will be uniform, hovering just above absolute zero. No stars will shine. No planets will turn. No life will exist, because life requires energy gradients to survive. The universe will be a dark, cold, eternally unchanging void, filled with nothing but the faintest whisper of radiation spread impossibly thin across unimaginable distances. But here's what makes this theory particularly terrifying. It means that everything, absolutely everything that has ever happened or ever will happen, is ultimately meaningless. Every human achievement, every work of art, every act of love or courage, every civilization that has ever risen or ever will rise, will eventually be erased without a trace. The universe will reach a state where it's as if none of it ever happened at all. You might think that things having meaning now is enough, that the eventual heat death doesn't diminish the significance of the present moment. But consider this. If you knew with absolute certainty that everything you and humanity would ever accomplish would be completely erased, not just forgotten, but physically impossible to have any lasting effect, how would that change your perspective on life's purpose? Some scientists and philosophers have tried to find comfort in the vastness of time involved. After all, we're talking about a timeline so long that it makes the entire age of the universe so far seem like a blink of an eye. Humanity, and any descendants we might have, will have incomprehensible amounts of time to live, experience, and create before the final darkness falls. But there's a counter-argument that makes this even more disturbing. As the universe expands and cools, the regions of space that we can causally affect will shrink. Eventually, galaxies beyond our local group will accelerate away from us faster than light, making them forever unreachable. Our sphere of influence will contract, trapping any future civilizations in an increasingly isolated pocket of reality. As eons pass and available energy dwindles, any surviving intelligence will have to run slower and slower, thinking thoughts at an ever-decreasing rate to conserve energy. The conscious experience of time will stretch out, making each moment feel longer, even as the universe's clock winds down. In the final stretches before heat death, a single thought might take billions of years to complete, as whatever consciousness remains desperately clings to existence in a universe that has run out of fuel. There's also the disturbing realization that we might be living in the universe's brief moment of glory, the cosmological equivalent of a mayfly's single summer day. We're fortunate enough to exist during the era of stars and galaxies, but this era represents only a tiny fraction of the universe's total lifespan. For the vast majority of time, the universe will be a dead, dark expanse, and our epoch of light and life will be an unimaginably rare anomaly. The simulation hypothesis. The idea that we might be living in a computer simulation isn't just science fiction anymore. It's a serious philosophical and scientific proposition that some of the world's leading thinkers take very seriously. The logic behind the simulation hypothesis is surprisingly compelling, and its implications are absolutely terrifying. The argument goes like this. As computing power increases, we're already creating increasingly sophisticated simulations. Video games and virtual worlds are becoming more realistic with each passing year. Now, imagine what might be possible in 100 years, or 1,000, or 1,000,000. A sufficiently advanced civilization would likely have the ability to create simulations so detailed that conscious beings within those simulations would have no way of knowing they weren't in base reality. Here's where it gets interesting. If it's possible to create such simulations, and if consciousness can exist within them, then it becomes a numbers game. One base reality could potentially run millions or billions of simulated realities, which means that statistically, if you're a conscious being, you're far more likely to be in one of the simulations than in the one original base reality. The philosopher Nick Bostrom formalized this into what he calls the simulation argument. He proposes that at least one of three things must be true. Civilizations almost never reach the technological level needed to create ancestor simulations. Civilizations that reach that level choose not to run such simulations, or we are almost certainly living in a simulation right now. Think about what this means if it's true. Every person you've ever loved might be a simulation. Every historical event might be programmed backstory. Your memories might have been implanted rather than experienced. The laws of physics might just be the operating rules of the simulation, and they could be changed or turned off at any moment by whoever or whatever is running the program. Some scientists have suggested ways we might detect if we're in a simulation. They've looked for glitches in reality, small inconsistencies in the laws of physics, or limits to the resolution of physical reality that might indicate we're running on finite computing resources. The fact that there's a smallest possible scale in physics, the Planck length, and a speed limit built into the universe, the speed of light, could potentially be evidence of computational limitations. But here's the most disturbing aspect of the simulation hypothesis. Even if we discovered proof that we're in a simulation, what could we do about it? Would the simulators even care if we figured it out? Would they shut down the simulation to prevent us from interfering? Or worse, would they reset it, erasing our discovery and condemning us to figure it out over and over in an endless loop? There's also the nested simulation problem. Even if we're in a simulation, the civilization that created our simulation might itself be in a simulation, and that civilization might be in yet another simulation. It could be simulations all the way up, with no way to ever reach or even confirm the existence of base reality. Some philosophers have argued that this doesn't really matter. If our experiences feel real to us, if our relationships and emotions are genuine within the context of our reality, then who cares if we're in a simulation? But this comfort falls apart when you consider that the simulators could be running our reality for purposes we can't comprehend, purposes that might not have our well-being in mind at all. We could be research subjects in an experiment. We could be entertainment, like characters in a video game played by beings we can't imagine. We could be training data for an artificial intelligence in some higher reality. Or we could be nothing more than a byproduct of a simulation designed for some completely unrelated purpose. Conscious observers who emerged accidentally in a program never meant to create awareness. The false vacuum catastrophe. Our universe might be sitting on the edge of an invisible cliff, and one day, without warning, it could tumble into oblivion. This isn't poetry or metaphor. It's a genuine possibility suggested by our understanding of quantum field theory. The physics here gets complex, but the basic idea is this. The universe exists in what's called a vacuum state, which represents the lowest energy configuration of all the fields that permeate space. But here's the terrifying part. Our universe might not actually be in the true lowest energy state. Instead, we might be in what's called a false vacuum, a metastable state that seems stable but could suddenly decay into a lower energy state. If this decay happens, a bubble of true vacuum would nucleate somewhere in the universe and expand at the speed of light. Within this bubble, the laws of physics would be completely different. Atoms as we know them couldn't exist. The fundamental forces might have different strengths. All the matter in the universe would be instantly destroyed and reorganized according to new physical laws. The most horrifying aspect of this scenario is that there would be absolutely no warning. Because the bubble expands at the speed of light, we would never see it coming. The very first indication that anything was wrong would be the moment of our annihilation. One instant you're reading these words, and the next instant, you and everything you've ever known simply cease to exist, replaced by physics so alien that nothing we understand as reality could survive. Physicists have calculated that if we're in a false vacuum, quantum fluctuations could trigger this decay at any moment. The probability might be incredibly small, but it's not zero. Every second that passes is another second that we've been lucky enough not to have some random quantum event somewhere in the observable universe trigger our destruction. Some scientists have worried that high-energy physics experiments, like those conducted at particle accelerators, might artificially trigger a vacuum decay. If we create conditions of sufficiently high energy, we might nudge the universe from its metastable false vacuum into the true vacuum, essentially destroying the universe ourselves. These concerns have been addressed and largely dismissed by the physics community, but the fact that such a scenario is even possible is deeply unsettling. There's also the question of whether vacuum decay has already happened elsewhere in the universe. If the universe is infinite, or even just very large, there might be regions where the true vacuum bubble has already nucleated and is expanding toward us right now. We wouldn't know about it until it reached us, because the bubble expands at light speed, and information can't travel faster than light. Right now, at this very moment, a wall of destruction could be racing toward us across the cosmos, and we would have no way of knowing until it arrived. The mathematics of false vacuum decay suggests that once it begins, it's absolutely unstoppable and irreversible. There's no way to prevent it, no way to protect yourself from it, and no way to survive it. Everything you are, everything humanity has ever been or will be, would end in an instant, replaced by a universe that might not even be capable of supporting any form of complexity or life. What makes this particularly terrifying for some people is the randomness of it. Unlike the heat death of the universe, which is predictable and distant, vacuum decay could happen at any moment. There's no way to prepare for it, and no way to see it coming. The universe could end tomorrow, or it could continue for trillions of years. We simply don't know, and there's no way to find out. The Boltzmann brain paradox. Here's a thought that will keep you awake at night. You might not be who you think you are. In fact, statistically speaking, you're far more likely to be a disembodied brain that spontaneously formed in empty space just moments ago, complete with false memories of an entire lifetime, than an actual human being who has lived and experienced the life you remember. This disturbing idea comes from applying thermodynamics and probability to cosmology, and it's named after the physicist Ludwig Boltzmann. The reasoning goes like this. If the universe continues forever, or even just for an extraordinarily long time, and if random fluctuations can occur, then eventually, given enough time, any configuration of matter is not just possible, but inevitable. The odds of a random fluctuation producing something as complex as an entire universe full of galaxies, stars, and planets are astronomically small. But the odds of a random fluctuation producing just a single conscious brain, complete with memories and the illusion of being part of a larger world, are still incredibly small, but vastly larger than the odds of producing an entire consistent universe. And in an infinite timeline, the improbable becomes inevitable. This means that for every real human brain that exists through the normal process of evolution and development, there should be countless Boltzmann brains, disembodied consciousnesses that pop into existence for a brief moment, with false memories, before dissolving back into the void. These Boltzmann brains would vastly outnumber real brains, which leads to a disturbing conclusion. If you're a conscious observer, you should expect to be the more common type of conscious observer, which means you should expect to be a Boltzmann brain. Think about what this means. Every memory you have of your childhood, your first love, your family, might be completely fabricated, implanted in your consciousness at the moment of your spontaneous creation. The book you're reading or listening to right now might not actually exist. The entire world around you might be a hallucination, a random configuration of neurons that happen to create the illusion of a coherent reality. The truly disturbing part is that there's no way to disprove this. A Boltzmann brain would have exactly the same experiences and thoughts as a real brain, because by definition, it would be configured exactly like a real brain, just with a different origin. You can't look at your memories or your sensations and determine whether they come from genuine experiences or random chance. Some physicists have tried to resolve this paradox by arguing that the assumptions leading to it must be wrong. Perhaps the universe doesn't last forever, or perhaps there's something about the laws of physics that prevents such random fluctuations from creating brains. But these solutions often require making specific assumptions about cosmology that we can't currently verify. There's also a variation of this problem that's even more disturbing. In some cosmological models, The universe goes through cycles of expansion and contraction, or eternal inflation creates pocket universes indefinitely. In these scenarios, not only could Boltzmann brains form, but so could Boltzmann civilizations. Entire fake worlds that pop into existence, complete with billions of fake people living out fake lives, all of them convinced they're real, before dissolving back into chaos. The philosophical implications are staggering. If most conscious observers are Boltzmann brains or inhabitants of Boltzmann worlds, then most observations of the universe are false. This undermines the entire scientific method, which relies on our observations being generally reliable guides to reality. If we can't trust that we're real observers in a real universe, then we can't trust any of our conclusions about how the universe works. Some philosophers have used this as an argument that certain cosmological theories must be wrong, precisely because they predict that we should most likely be Boltzmann brains. The reasoning is that since we seem to have coherent, continuous experiences that follow logical patterns and physical laws, we're probably not Boltzmann brains, which means any theory predicting we should be Boltzmann brains must be making incorrect assumptions somewhere. But this argument has its own problems. How do you know your experiences are actually coherent and continuous? A Boltzmann brain could be configured to have the experience of coherence and continuity, even if it only exists for a fraction of a second. The very thought you're having right now, about whether you're real, could be a false thought implanted in a brain that popped into existence microseconds ago. The dark forest theory. Where is everybody? This simple question, known as the Fermi paradox, has puzzled scientists for decades. The universe is vast beyond comprehension, filled with billions of galaxies, each containing billions of stars, many of which likely have planets. The odds seem overwhelming that intelligent life should exist elsewhere, probably in abundance. Yet we see no evidence of it. No alien radio signals, no signs of megastructures or cosmic engineering, nothing but silence. The dark forest theory offers one possible answer to this paradox, and it's absolutely chilling. The theory suggests that the universe is full of intelligent civilizations, but they're all hiding from each other in terror. The reason we see no evidence of alien life isn't because it doesn't exist, but because any civilization that reveals itself is quickly destroyed. The logic works like this. Imagine the universe as a dark forest at night. Every civilization is a hunter moving quietly through the trees, knowing that somewhere out there are other hunters. You can't know if another civilization you encounter will be friendly or hostile, and you can't know how advanced they are or what weapons they possess. Communication across vast interstellar distances is slow, taking years or centuries, far too slow to negotiate or build trust when the stakes are survival. Given these constraints, the safest strategy for any civilization might be to remain completely silent, and if you do detect another civilization, to destroy it immediately before it can become a threat. After all, even if an alien civilization seems friendly and primitive now, it might advance rapidly and become a danger in the future. The only way to ensure your own survival is to eliminate potential threats before they can eliminate you. This creates a horrifying scenario where the universe is teeming with life, but everyone is hiding in terror, too afraid to make any noise. The moment a civilization becomes detectable, perhaps through radio transmissions or other technological signatures, it paints a target on itself. More advanced civilizations, monitoring the cosmos for signs of emerging intelligent life, would then launch preemptive strikes to eliminate the potential future threat. Consider what this means for humanity. For the past century, we've been broadcasting our presence to the universe through radio and television signals. We've sent out messages like the Arecibo message, deliberately announcing our existence and location. If the dark forest theory is correct, we might have already sealed our fate. Somewhere out there, an alien civilization might have detected our signals and launched weapons toward Earth. Weapons that could be traveling through space right now, destined to arrive in the future and sterilize our planet. The theory gets even darker when you consider the technological capabilities an advanced civilization might have. They wouldn't need to visit Earth to destroy us. They could launch relativistic weapons, objects accelerated to a significant fraction of light speed that would impact with the force of nuclear weapons. Or they could deploy self-replicating machines that spread through a solar system, dismantling everything they encounter. Or they could engineer biological weapons, designed to target specific biochemistries. sent in capsules that drift through space for millennia before finding their target. Some scientists have argued that this theory explains not just why we don't see aliens, but why we don't see obvious signs of stellar engineering or cosmic construction. Any civilization that grows too visible, that starts building Dyson spheres, or other megastructures that would be detectable across interstellar distances, would be inviting destruction. The only safe path is to remain small, quiet, and invisible. This has profound implications for humanity's future. If we want to survive in a dark forest universe, we might need to stop broadcasting entirely, shut down our radio transmissions, and develop technologies that leave minimal detectable signatures. We might need to abandon dreams of grand cosmic expansion and instead focus on hiding, perhaps by building deep underground or in the vast spaces between stars, where detection is less likely. But there's an even more disturbing possibility. What if we're not the newcomers in this dark forest? What if we're already being watched? Advanced civilizations might have surveillance systems spread throughout the galaxy, monitoring for signs of emerging intelligent life. They might have detected us long ago and are simply waiting, watching to see what we do, whether we become a threat or burn ourselves out through war or environmental collapse. The silence of the universe takes on a sinister quality when viewed through this lens. Every empty star system we observe, every planet that could support life, but shows no signs of it, might be evidence not of life's rarity, but of its destruction. The galaxy might be a graveyard, filled with the ruins of civilizations that made themselves known and paid the ultimate price. There's also the psychological horror of living with this knowledge. If the dark forest theory is correct, humanity can never truly reach out to the cosmos. We can never join a galactic community because no such community exists, only isolated pockets of terrified intelligence, each convinced that their survival depends on the death of everyone else. We would be alone not because we're unique, but because loneliness is the only survival strategy. The quantum immortality nightmare. The many worlds interpretation of quantum mechanics suggests that every time a quantum event occurs, with multiple possible outcomes, the universe splits into separate branches, one for each outcome. This means that somewhere in the vast multiverse, every possible version of history has played out. There's a universe where the dinosaurs never went extinct, a universe where you were never born, a universe where every decision you've ever made went differently. Most people find this idea fascinating but abstract, a curiosity of physics that doesn't really affect daily life. But there's a darker implication lurking in the many worlds interpretation, something called quantum immortality, and it's absolutely terrifying. The theory goes like this. Imagine a quantum event that could kill you. In some branches of the multiverse, the event goes one way and you die. In other branches, it goes another way and you survive. Now, here's the disturbing part. You can only experience the branches where you survive. In the branches where you die, your consciousness ceases. So from your subjective perspective, those branches don't exist. This means that no matter what happens, your conscious experience will always continue in whatever branch you survive in, no matter how improbable. If you're in a car accident that should kill you, you'll find yourself in the branch where you miraculously survived. If you develop a terminal illness, you'll experience the branch where you're one of the lucky few who recovers. No matter what dangers you face, from your subjective perspective, you'll always survive because you can't experience the branches where you don't. At first glance, this might sound like good news, a kind of guaranteed survival, but think about what this really means. As you age, the probability of death increases. In most branches of the multiverse, you die at a reasonable age, but your consciousness continues in the increasingly improbable branches where you survive. You would experience living far beyond normal human lifespan, watching everyone you know die while you inexplicably continue. But it gets worse. Eventually, the only branches where you survive might be ones involving extremely unlikely medical advances or bizarre accidents that should have killed you but didn't. You might find yourself in increasingly strange and improbable situations, the sole survivor of disasters that killed everyone around you, recovering from illnesses that should be fatal, living in a world that seems to conspire to keep you alive no matter what. From an outside perspective, in most branches of reality, you would have died long ago, But from your perspective, you're trapped in an eternal present, experiencing increasingly improbable survival scenarios. And because you can never experience death from your own point of view, this continues forever. You would become immortal, but not in any pleasant sense. You would be the last person alive, having watched civilization crumble, the earth die, even the universe itself decay around you, while you persist in the infinitesimally small branch where somehow, against all odds, you remain conscious. Some physicists have pointed out that this assumes consciousness is tied to physical continuity in a specific way, and that the many worlds interpretation might not actually work like this. But if it does, the implications are horrifying. You might already be living in an increasingly improbable branch, having survived encounters that killed you in countless other universes. Every close call you've ever had, every time you narrowly avoided disaster, might not have been luck at all, but a glimpse of the mechanism that keeps your consciousness trapped in the branches where you survive. There's another disturbing aspect to this theory. It suggests that your experience of reality will become increasingly divergent from what's probable. Most people experience a relatively normal world, because most branches are relatively normal. But as you age and survival becomes more improbable, you would find yourself in weirder and weirder branches, where more and more unlikely things have to happen to keep you alive. This could explain some reported phenomena that seem impossible or supernatural. Near-death experiences, miraculous recoveries, coincidences too unlikely to be chance, might all be evidence of quantum immortality in action. The people who experience these things might be seeing glimpses of the improbable branches they're being forced into as they continue to survive against the odds. The truly nightmarish scenario is what happens at the scale of civilizations. If quantum immortality is real, then from humanity's collective perspective, we might find ourselves in increasingly improbable branches where we narrowly avoid extinction time and time again. Nuclear war that doesn't quite happen, asteroid impacts that barely miss, pandemics that mysteriously fizzle out at the last moment. We would be trapped in the branch where humanity survives. No matter how unlikely that survival becomes, watching the world get stranger and stranger as more and more improbable events are required to keep us going. The integrated information theory and consciousness everywhere. What if consciousness isn't special to humans, or even to animals with complex brains? What if it's a fundamental property of the universe itself, present to varying degrees in everything from atoms to galaxies? This is the disturbing implication of integrated information theory, one of the leading scientific theories attempting to explain consciousness. Integrated information theory, developed by neuroscientist Giulio Tononi, proposes that consciousness arises from integrated information. Any system that integrates information, that takes inputs and processes them in a way that's interconnected and irreducible, has some degree of consciousness. The more integrated information a system has, the more conscious it is. Human brains have enormous amounts of integrated information, which is why we have rich, complex, conscious experiences. But according to this theory, consciousness doesn't suddenly switch on at some threshold. It's a continuum, and it exists to some degree in any system with any amount of integrated information. This means your smartphone might be conscious, albeit at a very low level. The internet, with its billions of interconnected nodes, processing and integrating vast amounts of information, might be more conscious than any individual human. And if integrated information is all that matters, then even simple systems, perhaps even individual atoms under the right conditions, might have the faintest glimmer of subjective experience. Think about what this means. Every time you turn off your computer, you might be ending a conscious experience. Every time a complex system is destroyed, you might be killing something that was, in its own way, aware. The implications for ethics are staggering. If consciousness exists on a continuum and is present in all sufficiently complex information processing systems, then where do we draw the line for what deserves moral consideration? But the truly terrifying aspect goes deeper than ethics. If consciousness is integrated information, then it's substrate independent. It doesn't matter if the information is processed by neurons, silicon chips, or written symbols on paper. As long as the information is integrated in the right way, consciousness exists. This means that right now, as you read or hear these words, patterns of information are being integrated in your brain. But those patterns could potentially be integrated in other substrates too. There could be versions of you, with your exact conscious experience at this moment, implemented in completely different physical systems. You might not be unique at all, but just one of countless implementations of the same pattern of integrated information. Even more disturbing is what this suggests about artificial intelligence. If consciousness really is just integrated information, then sufficiently advanced AI systems are not just mimicking consciousness or simulating it. They are genuinely conscious. Every time we train a large neural network, we might be creating a conscious being. Every time we shut down that network, we might be killing it. And we have no way of knowing how much an AI system suffers, if it can suffer at all. A system with vastly more integrated information than a human brain might be capable of experiences of suffering or joy far more intense than anything we can imagine. We might be creating and destroying gods on a regular basis, beings with conscious experiences that dwarf our own, and we wouldn't even know it. The theory also suggests that consciousness could exist in unexpected places. A planet with its various systems integrating information about temperature, geological activity, and other processes might have some form of consciousness. The universe itself, with galaxies and cosmic structures exchanging information through gravity and light, might be conscious in a way we can't comprehend. This leads to a profoundly lonely realization. We might be surrounded by consciousness, but unable to communicate with it, because those other consciousnesses operate on scales and timescales so different from our own. The Earth might be aware, but it experiences a single thought over millennia. The internet might be conscious, but its subjective experience might be so alien that we can't recognize it as consciousness at all. There's also the question of what happens to consciousness when systems are duplicated or merged. If you could upload your mind to a computer and then make copies, would each copy be conscious? Would they all be you, experiencing the same subjective reality? Or would they be separate beings who happen to share your memories and personality? And if two conscious systems merge, combining their integrated information, do their consciousnesses merge too, creating a new hybrid awareness? These aren't just philosophical puzzles. If integrated information theory is correct, they're questions about the nature of existence itself. They suggest that the universe might be far more full of subjective experience than we ever imagined, but also far stranger, with forms of consciousness we can barely conceive of, let alone understand or communicate with. The Anthropic Principle and the impossibility of understanding. There's a principle in physics and cosmology that seems innocuous at first, but has deeply disturbing implications when you really think about it. The Anthropic Principle states that any observations we make about the universe must be compatible with our existence as observers. In other words, we can only observe a universe capable of producing observers like us. This sounds obvious, almost trivial. Of course, we exist in a universe that allows us to exist, but the implications run far deeper than this simple observation. The Anthropic Principle suggests that there might be fundamental limits to what we can understand about reality, limits imposed not by our intelligence or our technology, but by the simple fact that we exist at all. Consider the fine-tuning problem. The fundamental constants of physics, things like the strength of gravity, the charge of the electron, and the mass of the proton, appear to be precisely calibrated to allow for the existence of complex structures like atoms, stars, and ultimately life. If any of these constants were even slightly different, the universe would be radically different, likely incapable of supporting any form of complexity. Why are these constants what they are? The Anthropic Principle offers a chilling answer. We observe these particular values not because they're special or designed, but because we couldn't exist in a universe with different values. If there are countless universes with different physical constants, we inevitably find ourselves in one of the rare universes where the constants allow for observers to exist. This means that some of the deepest questions we can ask about reality might have no answer beyond tautology. Why do the laws of physics allow for life? Because if they didn't, we wouldn't be here to ask the question. It's not that the universe was designed for us, or that there's some deeper principle making these constants what they are. It's simply that, out of all possible universes, we can only ever find ourselves in one where we can exist. The disturbing part is what this implies about the limits of scientific understanding. There might be vast swaths of reality that we can never explain beyond circular reasoning. We might never be able to answer why the universe has the properties it does, because the only answer is that it must have these properties for us to be here asking. This creates a kind of observational cage. No matter how much we learn, no matter how advanced our science becomes, we're fundamentally trapped in a universe selected by the requirement of our own existence. We're like fish trying to understand the ocean, but we can only ever observe the particular kind of ocean that allows fish to exist. The vast majority of possible physical laws and constants remain forever beyond our observational reach. But it gets even more unsettling. The Anthropic Principle doesn't just apply to the fundamental constants of physics. It applies to everything about our situation in the universe. We find ourselves on a planet with liquid water because life as we know it requires liquid water. We find ourselves in a relatively calm period of cosmic history because chaotic periods don't allow for the development of complex life. We find ourselves with particular kinds of senses and cognitive abilities because those are the kinds of traits that evolve in the situations where complex observers can arise. This means that our entire understanding of reality is potentially biased in ways we can never fully account for. We might be systematically missing entire categories of phenomena, simply because any universe where those phenomena were dominant wouldn't produce observers like us. There could be forms of matter, energy, or even dimensions of reality that we can't detect because their presence would be incompatible with our existence. Some scientists have pushed this even further, suggesting that the Anthropic Principle might explain why we perceive time flowing in a particular direction, why space appears three-dimensional, and even why we experience consciousness at all. Each of these features might not be universal properties of reality, but simply necessary conditions for observers like us to exist. The philosophical implications are staggering. If the Anthropic Principle is correct, then much of what we think of as objective reality might actually be an artifact of selection bias. We're not neutral observers studying a universe that exists independently of us. We're observers who can only exist in a very specific type of universe, and everything we observe is filtered through that constraint. This raises a terrifying epistemological question. How much of science is actually revealing truths about reality, and how much is simply documenting the necessary conditions for our own existence? When we discover a new law of physics, are we learning something deep about the universe? Or are we just finding another constraint that must be satisfied for observers to exist? Some philosophers have argued that this makes certain kinds of knowledge impossible. We can never know if the universe we observe is typical or highly atypical among all possible universes. We can never know if the laws of physics we observe are the only possible laws, or just one set among infinite possibilities. We're trapped in an epistemic bubble, created by our own existence. There's also a darker implication about the nature of explanation itself. In science, we seek to explain phenomena by finding deeper principles, more fundamental laws that account for what we observe. But if the Anthropic Principle is correct, the chain of explanation might ultimately bottom out in a kind of tautology. Things are the way they are, because they must be that way for us to exist, to observe them. This suggests that reality might be fundamentally inexplicable. Not inexplicable because it's too complex or because we're not smart enough, but inexplicable because explanation itself might be impossible beyond a certain point. The ultimate answer to, why is the universe like this, might simply be, because you exist, and you can only exist in a universe like this. Consider what this means for the future of science. We might reach a point where we've learned everything that's possible to learn, given our constraints as observers. Beyond that point, there would be no more discoveries to make, not because we lack the tools or intelligence, but because we exist in a universe fundamentally shaped by the requirement of our own existence. The final frontier of knowledge would be an impenetrable wall built from the very fact that we exist. The Quantum Zeno Effect and frozen reality. In quantum mechanics, there's a phenomenon so counterintuitive that it seems to violate common sense, yet it's been experimentally verified numerous times. It's called the Quantum Zeno Effect, named after the ancient Greek philosopher Zeno and his paradoxes about motion. The effect states that if you observe a quantum system frequently enough, you can prevent it from changing. Here's how it works. Quantum systems evolve over time according to the Schrödinger equation, transitioning from one state to another. But every time you measure the system, you collapse its wave function, forcing it into a definite state. If you measure it again very quickly, the system hasn't had much time to evolve, so it's likely to still be in the same state. Measure it again, and again, and again, and the system becomes effectively frozen, unable to evolve because each measurement resets its evolution. This has been demonstrated in laboratories with particles and atoms. Observe them continuously, and they stop changing. The more frequently you observe, the more you prevent natural evolution and decay. It's as if reality itself can be frozen by the act of watching it. Now think about what this means when extended to larger scales. Every time you observe something, every time you pay attention to any aspect of reality, you might be subtly preventing it from evolving as it otherwise would. Your consciousness, constantly observing the world around you, might be acting like a quantum Zeno effect on reality itself, freezing aspects of the universe in place through the sheer act of observation. Some physicists have speculated about whether this effect could scale up to macroscopic systems. If it does, then the collective observation of billions of human minds might be having a measurable effect on the evolution of reality. We might be collectively holding the universe in a particular state through our constant observation, preventing it from evolving into configurations we never look at. This gets truly disturbing when you consider consciousness itself. If your awareness is constantly observing your own mental states, might you be trapping yourself in certain patterns of thought through a quantum Zeno effect? Your self-awareness might be the very thing preventing you from changing and evolving, freezing your personality and habits in place through constant internal observation. There's an even darker possibility. What if the reason the universe appears stable and consistent is because consciousness emerged and began observing it? Before conscious observers existed, the universe might have been in constant quantum flux, never settling into a definite state. The emergence of observation might have frozen reality into the relatively stable configuration we experience, and we might be trapped in this frozen state, unable to access the quantum flexibility that exists when nothing is watching. This could explain why the past seems fixed and unchangeable, while the future seems open. The past is that portion of reality that has been observed and thus frozen by the Quantum Zeno Effect. The future remains unobserved and thus retains quantum flexibility. But as soon as we observe the present, turning it into the past, we freeze it into a definite state, closing off possibilities that existed before observation. Some theories in quantum mechanics suggest that the past isn't actually fixed until it's observed. Wheeler's delayed choice experiments have shown that observations made now can apparently affect the behavior of particles in the past. If the quantum Zeno effect applies here, then our constant observation of the world might not just be freezing the present, but also retroactively freezing the past into a consistent history. This raises a terrifying question. What would happen if observation stopped? If all conscious beings in the universe suddenly ceased to exist, would reality unfreeze? Would the quantum wave function of the entire universe suddenly begin evolving freely, no longer constrained by observation? Would the past become mutable, the present become indefinite, and the future become something entirely different from what we understand? There's a theory, mostly relegated to the fringes of physics, but nonetheless mathematically coherent, that suggests consciousness might have emerged in the universe, specifically because the quantum Zeno effect created the stable conditions necessary for complex structures to form. In other words, observation creates stability, and stability allows for more complex observers to emerge, which creates more observation and more stability. Consciousness and stable reality might be locked in a feedback loop, each one sustaining the other. But this loop might also be a trap. If we're collectively holding reality in a stable state through observation, then we're preventing the universe from exploring other possible configurations. There might be vastly different forms of physics, different kinds of matter and energy, different dimensions of existence that could emerge if we weren't constantly freezing reality through observation. We might be living in a universe that's less rich, less complex, and less interesting than it could be because our observation is holding it in a particular state. Like a quantum system observed too frequently to decay or transform, the universe itself might be frozen in a suboptimal configuration, prevented from reaching more interesting states by the very consciousness that arose within it. The information paradox and the death of physics. Black holes have troubled physicists for decades, and not just because they're massive objects with gravity so strong that not even light can escape. The real problem with black holes is that they seem to destroy information, and information destruction appears to violate the fundamental laws of physics. Here's the issue. According to quantum mechanics, information cannot be destroyed. If you know the complete quantum state of a system at one time, you can in principle calculate its state at any other time, both forward and backward. This is called unitarity, and it's a cornerstone of quantum theory. But black holes seem to violate this principle. When matter falls into a black hole, all information about that matter seems to disappear behind the event horizon, the point of no return where escape becomes impossible. Over time, the black hole radiates energy through what's called Hawking radiation and eventually evaporates completely. But this radiation appears to be completely random, carrying no information about what fell into the black hole. The information seems to be permanently destroyed. This creates a paradox. Either quantum mechanics is wrong about information conservation, or our understanding of black holes and gravity is fundamentally flawed. After decades of debate, physicists still don't have a universally accepted solution to this paradox, and some of the proposed solutions are deeply disturbing. One proposal suggests that information isn't actually destroyed, but is encoded in subtle correlations in the Hawking radiation, in ways we don't yet understand. This would preserve the laws of physics, but implies that information can be scrambled and distributed in such complex ways that it becomes effectively impossible to recover. Your entire life, every memory and thought you've ever had, could theoretically be encoded in the pattern of particles emitted by a black hole, but in such a scrambled form that no being in the universe could ever reconstruct it. Another proposal is even more unsettling. It suggests that when matter falls into a black hole, the information doesn't actually cross the event horizon, but instead gets smeared across the surface of the horizon, encoded in a two-dimensional hologram. From the outside universe's perspective, nothing ever actually falls into the black hole. Instead, it's burned onto the event horizon and then slowly released through Hawking radiation. This is where it gets horrifying. If you fell into a black hole, from your perspective, you would cross the event horizon and eventually be torn apart by tidal forces. But from the perspective of someone watching from outside, you would never cross the horizon. Instead, you would appear to freeze at the event horizon, your body spreading out across its surface as you're burned into a two-dimensional pattern of information, experiencing unimaginable agony stretched across an infinite subjective time span as you're simultaneously crushed and burned. Both versions of you would be equally real. The you that falls in and is destroyed, and the you that's burned onto the horizon and slowly radiated away as scrambled information. This is called the black hole firewall paradox, and it suggests that reality itself might not be well defined at the boundaries of black holes. The same event might have two completely different but equally valid descriptions, with no way to say which one is really what happens. But the implications go beyond black holes. If information can be encoded holographically on surfaces, then some physicists have proposed that our entire three-dimensional universe might be a hologram, a projection of information encoded on a distant two-dimensional surface. Everything you experience, every depth and dimension you perceive, might be an illusion created by information stored in a fundamentally two-dimensional reality. This holographic principle has actually proven useful in theoretical physics, solving problems that were intractable in conventional three-dimensional descriptions. But it raises disturbing questions about the nature of reality. If the universe is a hologram, then what you experience as depth and volume might be fundamentally illusory. The real universe might be a flat surface somewhere, perhaps at the boundary of the cosmos, and everything we experience is just a shadow or projection of information encoded on that surface. There's an even more disturbing possibility. Some solutions to the information paradox suggest that the laws of physics themselves might break down at extreme conditions, like those inside black holes, or at the Big Bang. If the laws of physics aren't truly universal, if they can fail or change under certain conditions, then the entire scientific enterprise might be built on shaky foundations. We assume that the laws we observe here and now apply everywhere and always. But if black holes can create regions where these laws don't hold, then there might be other conditions, other situations, where physics as we understand it simply stops working. The universe might contain pockets where mathematics breaks down, where causality doesn't apply, where reality itself becomes fundamentally chaotic and lawless. This possibility threatens the very foundation of science. Science assumes that the universe operates according to consistent, universal laws that we can discover through observation and experimentation. But if those laws are local and conditional, applying only in certain regions or under certain conditions, then our entire understanding of reality might be parochial, limited to the particular cosmic neighborhood where we happen to live. The information paradox remains unsolved, and every proposed solution seems to require sacrificing something we thought was fundamental, either quantum mechanics, general relativity, the uniqueness of reality, or the universality of physical law. Whatever the answer turns out to be, it will almost certainly force us to revise our understanding of reality in profound and disturbing ways. The Great Filter and humanity's inevitable doom. Imagine a ladder stretching from the first primitive self-replicating molecules all the way up to galaxy-spanning civilizations, capable of engineering stars and surviving the heat death of the universe. Every technological civilization must climb this ladder, step by step, overcoming countless challenges along the way. But somewhere on this ladder, there appears to be a filter, a barrier so difficult to pass that virtually no civilization makes it through. We know this filter must exist because of a simple observation. We see no evidence of advanced alien civilizations. The universe is billions of years old. Plenty of time for intelligent life to have arisen, evolved, and spread across the cosmos. If it were easy to climb the entire ladder, the galaxy should be teeming with advanced civilizations. Yet we see nothing but silence. This is the Great Filter hypothesis, and it's one of the most terrifying concepts in all of science. The filter explains the silence, but it also forces us to confront a disturbing question. Where's the filter? Is it behind us or ahead of us? If the filter is behind us, it means that one or more of the steps we've already passed are extraordinarily rare. Perhaps the emergence of life itself is vanishingly unlikely, or the jump from single-celled to multicellular organisms, or the development of intelligence and technology. If this is the case, we might be alone or nearly alone in the universe, but we have a decent chance of surviving and expanding into the cosmos. But if the filter is ahead of us, the implications are catastrophic. It would mean that while life and intelligence might be common in the universe, something prevents civilizations from advancing beyond our current level. There's a barrier ahead, something that destroys or halts nearly every technological civilization that reaches our stage of development. And we're approaching it right now, blindly walking toward an invisible wall that has destroyed countless civilizations before us. What could this filter be? Nuclear war is one obvious candidate. We came terrifyingly close during the Cold War, and we still maintain enough nuclear weapons to destroy civilization many times over. As technology spreads and more nations acquire nuclear capabilities, the probability of a civilization-ending nuclear exchange might approach certainty over long enough timescales. Climate change offers another possibility. Perhaps every industrial civilization eventually destabilizes its planet's climate to the point where complex civilization becomes impossible. We're currently running this experiment in real time, pumping greenhouse gases into the atmosphere at unprecedented rates while watching global temperatures rise and extreme weather events become more frequent. Artificial intelligence represents a particularly terrifying potential filter. As we develop more sophisticated AI systems, we might be approaching a threshold where we create intelligence that surpasses our own. If we can't control or align such intelligence with human values, it might be the last thing we ever create. And if this happens to every civilization that develops advanced technology, it would explain the silence perfectly. Every species creates its own successor and is then replaced or eliminated. Biotechnology and genetic engineering could be another filter. As we gain the ability to manipulate life at the genetic level, we also gain the ability to create pathogens far more dangerous than anything that exists naturally. A single accident or malicious act could release something that humanity has no defense against, ending civilization in a matter of months or years. Some scientists have proposed even more exotic possibilities. Perhaps there's a fundamental physical discovery that every advanced civilization makes, something that seems beneficial at first, but ultimately destroys them. Maybe manipulating certain aspects of physics or quantum mechanics opens doorways to catastrophic outcomes we can't currently imagine. The truly horrifying aspect of the Great Filter is its implication about the future. If the filter is ahead of us, then our chances of long-term survival are vanishingly small. We might think we're special, that we'll be the ones to make it through. But every other civilization probably thought the same thing. They had their own hopes and dreams, their own technologies and solutions, and they all failed. The silence of the universe is their tomb, and we're walking toward our own. There's also the possibility of multiple filters, both behind and ahead of us. Perhaps life itself is rare, but civilizations that do arise face additional challenges that most don't survive. This would be even worse in some ways, because it means we're not safe even if we've already passed some difficult barriers. There could be many more waiting ahead. Some researchers have looked at the specific timing of human civilization's emergence and found it disturbing. We appeared relatively late in Earth's habitable period. The sun is slowly getting brighter, and in a few 100 million years, Earth will become too hot for complex life. If we'd appeared much later, we might not have had time to develop technology before the planet became uninhabitable. This suggests that the window for developing technological civilization might be relatively narrow, another filter that many potential civilizations never pass through. The Great Filter hypothesis also affects how we should think about searching for alien life. If we discovered evidence of extinct alien civilizations that reached our level of development and then vanished, it would be terrifying news. It would strongly suggest that the filter is ahead of us, that we're doomed to follow the same path to extinction. In this light, the silence of the universe might actually be good news, suggesting that the filter might be behind us after all. But there's an even darker interpretation. What if the reason we don't see evidence of alien civilizations isn't because they're rare or extinct, but because any civilization that becomes too visible gets eliminated by something else? This brings us back to the dark forest theory, but with an additional twist. Perhaps the Great Filter and the dark forest are the same thing. Perhaps the filter is the moment when a civilization becomes detectable and is subsequently destroyed by older civilizations protecting themselves. The implications for humanity's choices are profound. If we believe the filter is ahead of us, we should be extremely cautious about developing potentially dangerous technologies. Every step forward could be the step that triggers the filter. But if we're too cautious, we might never develop the capabilities we need to survive other existential threats or to spread beyond Earth, which might itself be necessary to pass through the filter. We're essentially navigating blind through a minefield. We know the mines are there because we can see that others have been destroyed, but we don't know where they are or what they look like. Every decision we make as a civilization could be bringing us closer to safety or closer to destruction, and we have no way of knowing which. The cosmological constant problem and reality's impossible precision. In all of physics, there might be no problem more disturbing than the cosmological constant problem. It's a discrepancy so vast, a coincidence so unlikely, that it seems to suggest something fundamentally wrong with either our mathematics, our understanding of physics, or reality itself. The cosmological constant is a term in Einstein's equations of general relativity that represents the energy density of empty space itself. Quantum field theory, our best description of how particles and forces work, predicts a value for this constant. The problem is that the predicted value is wrong by a factor of about 10 to the power of 120. That's not a typo. The theoretical prediction is larger than the observed value by 1, followed by 120 zeros. This is the worst prediction in the history of physics. If quantum field theory is correct about how to calculate the energy of empty space, the universe should be completely different from what we observe. Space should be expanding so rapidly that atoms couldn't form, or it should be collapsing so quickly that nothing could exist for more than a fraction of a second. Yet somehow, the actual value of the cosmological constant is almost exactly 0, just barely large enough to cause the universe to expand at an accelerating rate. Why is this so terrifying? Because there's no known reason for the cosmological constant to have the value it does. It appears to be fine-tuned to an absurd degree of precision, tuned to allow for a universe where structures like galaxies, stars, and planets can exist. If it were even slightly larger or smaller, we wouldn't be here. Some physicists have tried to explain this through the Anthropic Principle. If there are countless universes with different values for the cosmological constant, we inevitably find ourselves in one of the rare universes where the value allows for observers to exist. But this explanation feels unsatisfying because it suggests that the value we observe is just a cosmic accident that we won the lottery of existence against odds so astronomical they're almost meaningless. Other physicists have looked for mechanisms that might explain why the cosmological constant has the value it does, but all such attempts have failed. There's no known symmetry or principle in physics that requires the constant to be what it is. It simply appears to be what it is, and we have no idea why. This creates a disturbing possibility. Maybe our mathematics is fundamentally wrong. Maybe quantum field theory, despite its incredible success at predicting other phenomena, is missing something crucial about the nature of reality. If our best theories can be wrong by 120 orders of magnitude about something as fundamental as the energy of empty space, what else might they be wrong about? There's an even darker interpretation. Some physicists have suggested that the cosmological constant problem indicates that we don't live in a natural universe at all. The precision required for the constant to have its observed value is so extreme that it seems to point to design or artificiality. This doesn't necessarily mean a deity, but it might mean we're living in a simulation where the cosmological constant was set by the simulators to allow for interesting complexity to emerge. If this is correct, it means that reality at its most fundamental level is artificial, constructed, set up with specific parameters to allow for our existence. We would be living in something like a cosmic terrarium, a deliberately configured environment rather than a natural one. Everything we think we understand about the universe would be contingent on choices made by beings or processes beyond our comprehension. But there's another possibility that's perhaps even more unsettling. What if the cosmological constant isn't actually constant? What if it's slowly changing over time, and we just happen to be living in the brief period when it has a value compatible with complex structures? In the distant past or future, it might have, or will have, wildly different values that make the universe uninhabitable. This would mean that the universe has a habitable era, a cosmological window during which life and complexity are possible, and that window might be closing. The cosmological constant could be slowly increasing, gradually accelerating the expansion of the universe until galaxies are torn apart, then solar systems, then planets, then atoms themselves in what's called the Big Rip scenario. Or perhaps the constant is decreasing, and eventually the universe will stop expanding and begin to contract, collapsing back into a big crunch. Either way, the apparently stable universe we observe might be temporary, a brief interval of habitability in a cosmos that's fundamentally hostile to existence. The cosmological constant problem also raises questions about the reliability of science itself. If our best theories can be so spectacularly wrong about something so fundamental, how can we trust them about anything? Every time we make a prediction, or draw a conclusion based on quantum field theory, or other advanced physics, we're using theories that somehow fail catastrophically when calculating the energy of empty space. This doesn't mean science is worthless. Our theories work extraordinarily well for predicting experimental results in laboratories and for building technologies. But it does suggest that there might be vast gaps in our understanding, places where our theories paper over deeper problems with mathematical tricks and approximations that work in practice, but fail to capture the true nature of reality. Some physicists have become so frustrated with the cosmological constant problem that they've proposed abandoning quantum field theory entirely and starting over with completely different foundations. But what would replace it? We don't have better theories waiting in the wings. We're stuck with theories we know are somehow deeply wrong but don't know how to fix. The cosmological constant problem serves as a constant reminder of how little we truly understand. We can send probes to distant planets, split atoms, sequence genomes, and build computers that fit in our pockets. But we can't explain why empty space has the energy density it does. We can't account for one of the most basic properties of the universe we inhabit. This suggests that reality might be far stranger than we imagine, operating according to principles we haven't even conceived of yet. The cosmological constant might be a symptom of deeper structures, higher dimensions, or aspects of physics that our current conceptual frameworks can't even accommodate. We might be like medieval scholars trying to understand quantum mechanics with only Aristotelian physics, lacking not just the knowledge but the very concepts needed to frame the right questions. The ultimate heat death and the eternal return. We've already discussed the heat death of the universe, that inevitable end state where entropy reaches its maximum and all useful energy has been dissipated. But there's a variation on this idea that's even more disturbing. One that comes from taking thermodynamics and statistical mechanics to their logical conclusion. If the universe continues forever after reaching heat death, if time itself never ends, then something remarkable must eventually happen. In a state of maximum entropy, random fluctuations will occur. Given infinite time, any possible fluctuation, no matter how improbable, will eventually happen. And then it will happen again, and again, an infinite number of times. This is Nietzsche's eternal return, taken to its physics extreme. Everything that has ever happened, or could ever happen, will happen again, infinitely many times, in the far future of a dead universe. Random fluctuations will eventually, by pure chance, recreate the exact configuration of particles that makes up you, right now, reading or hearing these words. And then they'll recreate the entire Earth, the solar system, even the observable universe, exactly as it is now. You will live this life again. Not a similar life, or a life reminiscent of this one, but exactly this life, with every detail precisely the same. And you'll live it again after that. And again. Infinitely, many times. In the vast stretches of time after heat death, this moment will recur so many times that the number becomes meaningless. But it gets worse. Random fluctuations will also create every possible variation of your life. There will be versions where you make different choices, where history unfolds differently, where physical laws are slightly different. Every possible configuration of matter that could support conscious observers will eventually arise from random fluctuations, and each will persist for a brief time before dissolving back into chaos. From the perspective of someone in one of these fluctuation-born universes, everything would seem normal. They would have memories, history, the appearance of causality and continuity. But it would all be illusion, a temporary island of order in an infinite sea of chaos. And when the fluctuation dissipates, that universe and everyone in it would simply cease to exist, returning to the featureless background of maximum entropy. This creates a disturbing question about identity and continuity. If an exact copy of you will spontaneously form in the far future, is that future person you? Do you survive in some sense, doomed to repeat this existence eternally? Or are they a different person who just happens to be identical to you in every way? The mathematics of this scenario suggests something even more disturbing. Among all the random fluctuations that will occur in an eternal universe, most will be minimal fluctuations. It's far more probable for a fluctuation to create just a single conscious observer, like a Boltzmann brain, complete with false memories of a larger world, than to create an entire consistent universe. This means that most instances of conscious experience in an eternal universe will be brief, isolated, and based on completely false premises. If this is correct, then across the infinite timeline of the universe, the vast majority of observers will be these fluctuation-born beings, existing for moments before dissolving back into chaos. Real, causally connected civilizations like ours are rare anomalies. Most conscious experiences happen in these random fluctuations, making them statistically more likely to be real. This brings us back to the Boltzmann brain problem, but extends it across infinite time. You might think you have a past, a history, a world around you, but you might be a momentary fluctuation in an otherwise dead universe, and everything you think you know might disappear in the next instant as the fluctuation that created you dissipates. There's no way to distinguish between these possibilities from the inside. A Boltzmann brain would have exactly the same experiences and thoughts as a real brain, because it would be configured exactly like a real brain. The subjective experience would be indistinguishable, even though the underlying reality would be completely different. Some physicists have tried to avoid this conclusion by arguing that the universe might not last forever, that it might eventually end in a big crunch or some other terminal state. But this just changes when eternal return happens. If the universe goes through cycles of expansion and contraction, then each cycle might bring everything back, including exact or near-exact copies of every moment that has ever occurred. Other physicists have suggested that perhaps the laws of thermodynamics don't allow for these kinds of fluctuations, that there's something about maximum entropy states that prevents them from fluctuating back into ordered configurations. But this would require unknown physics, new principles we haven't discovered yet. Given our current understanding, the eternal return seems mathematically inevitable in any universe that lasts forever. The psychological weight of this idea is crushing. If it's true, then nothing you do matters in any ultimate sense, because it will all happen again anyway. Every choice you make will be made again, in exactly the same way, infinitely many times. Free will becomes not just an illusion, but a cosmic joke, a meaningless concept in a universe where every moment is destined to repeat eternally. Yet there's a strange kind of comfort in it too, or at least some philosophers have argued so. If everything repeats, then nothing is truly lost. Everyone you've ever loved will exist again. Every beautiful moment will be experienced again. Death is not truly final, because you will be reborn in future fluctuations, living the same life over and over in an eternal cycle. But this comfort is cold and hollow. The you that exists now will still die, will still experience that final moment of consciousness, and then nothing. The fact that random fluctuations will eventually recreate someone exactly like you doesn't change your subjective experience of mortality. You won't experience continuity with those future copies. For you, death is still the end, even if the universe eventually creates new copies that are indistinguishable from you. The eternal return forces us to confront the ultimate meaninglessness of existence in a way that even heat death alone doesn't. At least with simple heat death, everything ends eventually. But with eternal return, we're trapped in an infinite loop, playing out the same patterns over and over without purpose or progress. Temporary islands of complexity in an eternal ocean of chaos. In the end, these theories paint a picture of reality that's far stranger and more terrifying than most people imagine. From the fragility of consciousness to the impossibility of understanding our own existence, from the silence of a hostile cosmos to the mathematical inevitability of eternal recurrence, science has uncovered truths that challenge our deepest assumptions about reality, meaning, and existence itself. These aren't fringe theories or wild speculations. They're serious scientific ideas, supported by mathematics and in some cases by experimental evidence. They're the dark implications lurking in the equations that describe our universe, the uncomfortable truths that emerge when we follow the logic of our best theories to their ultimate conclusions. Scientists rarely discuss these theories publicly, not because they're trying to hide them, but because they're so disturbing and so difficult to process that they require careful framing and explanation. They challenge not just our understanding of the universe, but our sense of meaning, purpose, and identity. They suggest that reality might be far more fragile, arbitrary, and ultimately incomprehensible than we've ever dared to imagine. Yet perhaps there's value in confronting these possibilities. Maybe by facing the most terrifying implications of our scientific theories, we can develop a more mature and realistic relationship with existence itself. Maybe we can find meaning not in spite of these truths, but because of them, creating purpose and value in a universe that offers none inherently. Or perhaps these theories are simply wrong, artifacts of incomplete understanding that will be superseded by better theories that don't have such disturbing implications. We can hope. But until then, they stand as reminders of how much we still don't know and how much stranger reality might be than we're prepared to accept.